Let's solve homework exercise number 32 from section 2.3. It says use the bar graph at the right to show the percentage of boys. The bar graph to the right shows the percentage of boys and girls asking for various types of toys in letters to Santa Claus. Okay, K is the toys requested by more than 25% of the boys, and M is the toy requested by less than 25% of the girls. Find the set K intersect M. So it must be in both. Intersection means common to both. So the toys requested by more than 25% of the boys. The boys are in green, so more than 25% would be only A, right? The green bar here only goes 25% is right there, right? It doesn't quite make it. So A is the only one with boys more than 25%. So that's the only one left. Now, is this toy less than 25% of the girls? The girls are in yellow. Yes, A is looks like it's about 8%. So A fits both descriptions. It's requested by more than 25% of the boys, less than 25% of the girls. That's the only one, right, that fits both of them in set that are in both K and M. So our answer, of course, would be toy A. Okay, that would be the only one. Again, intersection means it's got to be common to both. All right, exercise number 33. Various types of toys requested. K is a toy requested by more than 15% of the boys. M is a toy that's requested by less than 10% of the girls. K union M, okay, we're doing K union M. It's either in K or M. It's in one or the other, or it's in both. Okay, so what we're going to do is we're going to go through all the ones that are in set K. K is more than 15% of the boys. So set K is going to be 15% of the boys, definitely toy A, and 15% toy B is boys more than 50, and toy C is again past 20. So set K, and the boys here are going to be what? Looks like about 2%. So A, B, and C are the toys that are requested by more than 15% of the boys. Okay, set M is the toys requested by less than 10% of the girls. Okay, so M, less than 10%, the yellow. Okay, A is less than 10%. B is more than 10%. C is more than 10%, D is more than 10%, E is more than 10%, and so is F. So the only one that is less than 10% of the girls would be A, right? And now what? We're doing K union M in one or the other, so it's A, B, and C. We do include A, it's in both, and B and C is in K. Remember, it's one or the other. So the union of these, A, B, C, and A, is A, B, and C, which, of course, is choice A. Okay? Number 34. And this is involving politics. 12,166 people voted for a politician in the first election. 13,622 voted for him in the second election. 8,302 voted for him in the first and second elections. How many people voted for this politician in the first or second? Okay, so actually you can do a Venn diagram, or you can just use the formula. The number of elements in A or B, the first or second election, is the number of elements in A, first election, plus the number of people who voted for the second election minus the number of people that voted for him in both A and B, or the first and second election. So the number of elements in A, the first election, would be 12,166. The number that voted for him in the second election would be 3,621. minus the number that voted for him in both, which is 8,302, and that will give us the number that voted for him in either the first or second election, A union B, okay? So we can go ahead and do the computations on our calculator. All right, so we have the first election, 12,166, plus the number from the second election, 13,621, minus in both 8,302, and we get 17,485. All right, very good. Or you could, of course, draw a Venn diagram. And what you could do is, if you draw the Venn diagram, you have the first election and the second, and 8302 are in the first, are in both, right? So you got to put that in both. If there's 12,166 in the first, then what's left here would be 12,166 minus the 8302, right? We already accounted for 8302 of the first. That includes the 12,000 includes the 8,302 that voted in the first and second. So you would have a 4, 6, and 8. So you would have 3,864 there. And the same thing in the second. You have 13,621, but you've already accounted for 8302, so you would subtract. So you would get 5,319. So now what? You split them up. So now the first or second would be these three numbers added together. So 3864, 8302, and 5319. If you add those two together, you get 5, carry the 1, 8, 11, 14, carry the 1, 4, 12, and 5 is 17. And there's your 17,485, the same value we got by using the formula. Okay? So you can do it either with the formula or the Venn diagram. Very good. All right, number 35, A intersect A complement. Okay, now notice, remember, A would be all the elements in A. So like, let's say you have the universal is 1, 2, 3, 4, 5. And if A is equal to, say, 1 and 2, then A complement is what? Everything that's not in A but in the universal. So A complement would be 3, 4, and 5, right? So when you intersect A intersect A complement, these are in A, these are the ones not in A. Nothing's ever going to be this in both A and A complement, right? So it's always going to be the empty set. When you intersect these 1, 2, 3, 4, 5, common to both is nothing, it's always going to be the empty set. So that is definitely a true statement, okay? Okay, A union the empty set is equal to the empty set. Well, let's just say, like, let's say A is 1, 2, 3, right? Empty set has no elements, right? So when we take the set A, 1, 2, 3, union it with nothing, but remember, union is in one or the other. So we do have the 1, 2, and 3, right? Union is in this set, so the answer would be 1, 2, and 3, right? Which is always just going to be whatever's in A, right? Because we're never going to add anything, but we're always going to keep everything in A because union is in one or the other. So this should be A union in empty set should be equal to A. So that statement is definitely false, and the one we have is A intersect. What we said is what? There it is. A union the empty set is equal to whatever's in A. So B is the one we said, which is correct. All right, number 37, A intersect B equals B. Now notice again, if you just kind of say, if A has the elements 1, 2, 3, B has the elements, let's say 1 and 2, right? So if we take A intersect B, we're going to take whatever's common to both A and B, which would be what? 1 and 2, right? So that means if B is the answer, that means every element in B is also going to be what in A, right? Because we need everything in there. So that means B is really going to be a subset of A, right? In order for this intersection to be common, that means everything in B must also be in A, but we could have extra elements in A, right? Because the intersection is B. So the one that has B as a subset would be right here, right? Everything in B is also in A. This would represent, that's represented by that Venn diagram right there, okay? Again, A can be a little bit bigger, but everything in B must be in A in order for A intersect B to be equal to set B, okay? So we have D is indeed the correct answer. Okay, this concludes this session and all the problems from section 2.3. I hope this is your math instructor, Dr. Swerves. I hope you found these videos helpful. If you still need more help, send me an email through the Canvas, using the inbox through the Canvas course at the FSW portal, and I'll be more than happy to help you. Thank you very much.